Hello everyone, here in this video we would like to talk about Newton law of cooling. This transmission of laws, this kind of laws, when there is a difference between when there is a temperature difference between the body and surroundings. This laws could happen via conduction, convection, radiation, all of them, right? So the law says that the rate of emission of the heat, that is rate of emission of the heat, the rate of loss of heat energy of the body. That means when you have a body at a higher temperature, this is the body and the surroundings are at a lower temperature, is directly proportional to temperature difference between body and surroundings. We say a minus here because the rate of loss of heat energy to the surroundings when the temperature of the body is more than that of the surroundings is rate of loss. There is a decrease. Just to indicate it's a decrease, we are going to put a minus. Then dq by dt, proportionality can be eliminated with some constant b, depends on the nature of the medium and other parameters. Now I can write dq as per the definition of a specific heat of the material as amount of heat required to convert unit mass of substance to raise the temperature of unit mass of substance by 1 degree centigrade is defined as specific heat. From here I can write dq equal to ms dt, that is delta T, that is, be careful, this is change in temperature. So in the place of dq, I can write ms change in temperature delta T by dt. Be careful, what is there? Dt in the denominator is change in time. What is dt in the numerator is change in temperature. They are not same, we shall not cancel them, right? Equal to, I have substituted this dq value here in this equation, minus b, temperature of the body minus temperature of surroundings. These temperatures need not be in Kelvin like the other laws like Wien's displacement law. It can be in centigrade also. This implies rate of change of temperature. You can take this m and s to the other side, minus b by ms, temperature of the body minus temperature of surroundings. So rate of change of temperature or rate of loss of temperature equal to some constant, of course minus is symbolic, temperature of the body minus temperature of surroundings. So it's very clear that the rate of change of temperature, or the change in temperature with respect to time, if you try to draw a graph, taking time on x-axis and change in temperature on y-axis, according to Newton law of cooling, the name itself is telling you like Newton law of cooling. That means when a hot body is brought into a cold surroundings, how does the body loses its temperature or body loses its heat energy? This is how we can understand that. This is the kind of a graph we get it. Now if I simplify this further, equation further, I can say change in temperature by temperature of the body minus surroundings. Getting this to the other side can be written like minus k with respect to time is dt. Now this is in a small interval of the time, this much of change of temperature happens. If it is continued and it happens for a long interval of a time. So I want to tell you that again, that Newton law of cooling says that the rate of loss of heat energy or the rate of loss of temperature is directly proportional to temperature difference between the body and the surroundings. If the temperature difference is more between the body and surroundings, the loss of heat or loss of temperature happens quickly, and vice versa. What I mean by that is, say body temperature is 100 degrees centigrade, temperature of the body. Temperature of surroundings is 20 degrees centigrade. Now the difference between them is 80 degrees. Therefore, per minute dq by dt or dt change in temperature will be more. How much heat it will lose per minute or per second, or how much temperature it loses per second will be more. As the time passes, temperature of the body will reduce, say from 100 degrees centigrade to 90 degrees centigrade. Surroundings remain at 20. Now the difference is 70. So if I say this is dq by dt of the first case, dq by dt of the second case will be less than that of the dq by dt of the first case. It happens slowly as the temperature difference is less, and so on. It's as if like if you have more money than what's the minimum that you need, you spend quickly. As the money that you have becomes less and less with respect to your basic needs, you will start spending slowly. So that says that the Newton law of cooling says that the rate of loss of heat or temperature of a body is directly proportional to temperature difference between the body and the surroundings. That law is called Newton law of cooling, right? Now, for a small interval of time, we want it for all the time, so we can integrate the equation to get total time. Let's integrate the equation. Integral of dt, that is change in temperature by temperature of the body minus surroundings, equal to minus integral of k dt. This is the total time. So if you continue this derivation further, we know the formula as integral of 1 by x dx equal to log x. This is integral of 1 by tb minus ts and dt. So that implies this equation will be further transformed as log of temperature of the body minus temperature of surroundings space E equal to minus k. Integral of differentiation of t is t plus some constant will come. That's how we can get a equation. So it's very clear that c is a constant, t is the time, k is also a constant. Then I can write log of temperature of the body minus surroundings base E is directly proportional to the time. Means what? If you draw a graph between whom and whom, time and log of temperature of the body minus temperature of surroundings base E, that loss will happen in a proportionate way. The graph will be down like this. Now I can extend this discussion further, as this log is there, so I can take this log to other side, that is temperature of the, just to understand Newton law of cooling further, body minus surroundings is, take the e to the other side basing on the very definition of logarithm, e power of minus kt. We can write e power of minus kt. So temperature of the body is temperature of surroundings plus e power of minus kt can be written. It's all basing on the Newton law of cooling. So I want to conclude by saying Newton law of cooling says that the rate of loss of heat or rate of loss of temperature of a body via conduction and convection or radiation is directly proportional to temperature difference between the body and surroundings, and it happens only when there is a temperature difference. If temperature of the body equal to surroundings, there is no rate of loss itself. So more the temperature difference, quicker the loss, and vice versa. That can be further proved as rate of loss of heat or rate of change in temperature is directly proportional to temperature difference between body and surroundings. Correspondingly, you can get the graphs like this, right? People sometimes ask graphs also, and also ask some problems. Next video, we will solve a problem so that you can understand how to attend problems on Newton law of cooling. That's it. Thank you for watching.